Okay, well, hello everyone. My name is Nick DiOrio. I'm an engineer at NREL, and today I will be introducing the SAM Open Source and SDK Virtual Workshop for 2019. As listed on the SAM website and previously described to some of the people on the phone, we have a schedule for today where I will introduce SAM's open source and SDK and some of the latest changes in those products. And then we'll move to focus on one particular part of the SDK called PySAM that Darius Guite, also here at NREL, has developed. And then we're going to move into some special topics from folks outside of NREL that have used SAM's SDK to build their own workflows and products. And so we'll be learning about how Sundat has integrated SAM with Yaya, and then moving into integrating SAM with a web portal for PV consumers in Saudi Arabia with Russ. We'll also listen to an innovative use of the SDK for integrating SAM for rural microgrid load modeling. And then we're going to finish up the workshop today with a video from Yassine, who has been looking at doing hydrogen production from variable renewable energy sources. And so the main motivation of this workshop is to give our users and potentially interested parties just some introduction to the open source code and software development kit that goes beyond the traditional desktop application that SAM is best known for, because we believe that the ability to make SAM extensible is one of the main selling points of the platform and really powers people to build upon what we've done. And so for the open source in particular, we consider benefits to be that you can inspect the underlying implementation of the performance or financial models. You can add custom functionality or additional features in your products. And you can also contribute and become part of our community, which we really encourage. And so here on the SAM team, we actively support folks who want to develop extensions to our models and add new models. And so as some recent examples of that, we've accepted contributions for developers who have written new module models and extended work that we've done in bifacial modeling and so on. And moving on from the open source, another powerful usage of SAM is through the software development kit, where you can wrap SAM in your project and then access models of interest via public interfaces. And so I've demonstrated that here on the bottom right hand side, where there's some software stack where in this case I've assumed that you're developing a smartphone app, and so you have your iOS or Android operating system, and then on top of that you could install the SAM SDK, and then your application layer would call the SAM SDK, add in any special features or value-added products that would allow you to market or sell your application. And in that case, you'd never have to recode a solar position algorithm. You'd never have to recode a PV model. You could simply access what we've already done and use it to do something that you actually want to do. And so these are perhaps two slightly separate use cases, but both relevant to making SAM more accessible. And so today in my introduction, I'm just going to give a brief overview of SAM's open source and software development kit, including some possible areas of interest. I'd just also like to highlight that this virtual conference is one of a series of webinars that we've given this year. And so there's one more webinar this year after this virtual conference that will be about modeling fuel cells in SAM. And all of these previous webinars are available on YouTube. And if you go to this URL here, you can learn about where those links are posted, as well as future events. So as many people on the phone probably know and are familiar with, SAM is a free software traditionally used as a desktop application for monitoring. Sorry, I think we had some feedback there. So it's a free software for modeling the performance and economics of renewable energy products. And we actively maintain and release new versions of SAM compiled from the open source repositories. And so the thing to note here is that any code that goes into the open source is actually code that we will eventually release into an NREL branded product. And so we're not, at this point, releasing separate versions that are built off an open source branch or a proprietary branch. And so any contributions to SAM are largely intended to be made public in our platform. Moving into some of the way that the open source code is structured, our code is built on a stack of software. And so you have your traditional operating system, which we support Windows, OS X, and Linux of various flavors. There's a C++ compiler, and then we use WX Widgets, which is a open source graphical user interface framework that allows us to build user interface elements. And then on top of that, we have a few NREL libraries that have different functionalities, and these are all C++ 11 capable libraries. And so LK is a custom scripting language that is embedded into SAM. WEX is an extension of WX Widgets that allows, where we've built custom user interface widgets for SAM. And it also contains the DView project, which is a popular way to visualize time series data. And then moving into the more traditional pieces of SAM, which most people would think of when they think of SAM, is SSC, which is the SAM simulation core. And this contains the technology model libraries as well as the financial model libraries. And so PV Watts, the wind model, the CSP models, they are all in SSC. And this is also where the SAM SDK is built from. So the SAM SDK is essentially an API into SSC. And then finally, the SAM project is a graphical user interface that includes all of these projects in some component and provides kind of that sleek interface and experience. So all the code is publicly hosted on GitHub and accessible. And I just wanted to point out some of the traffic that we've got over the last couple years on the open source, just to give you an idea of what this looks like. And so on the bottom left, we're showing unique visitors, and you can see that the SAM project gets a lot of visitors every quarter, and that's primarily because people are first coming to the SAM repository and then going where they need from there. And then on the right, we have the unique clones of the different repositories, and in that, there's a little bit different trends where SSC is, at least in the last quarter that we reported here, was the most cloned. But otherwise, it's fairly equal because we assume that in this case, people are mostly interested in building SSC, which has some dependencies on the other repositories. And I'd also like to point out that these 4 repositories are all now licensed under a vanilla BSD3 clause license, which we did just to make things a little more clear. And so with the open source, as I mentioned, we're very interested in building a community and getting external contributions. And so I just wanted to highlight what our contribution process and policy actually looks like. And we've tried to make it very straightforward. And so there's just 3 simple steps that you can take. And the first one is to fork whatever repository that you want to add to. you make your modifications, or if it's a very large new feature, we'd suggest that you contact us before you start so we can just coordinate your contribution and understand what we'll need to do to support that. And then using GitHub, there's very easy tools that you can use to create a pull request, which is basically just a request for us to pull your code into our repository. And we have some additional help here that you can go through, and we're always happy to answer your questions or give you a hand on getting started. For the open source projects, we've really been focused on improving the code quality as the projects become larger, more complex, and there's more stakeholders. So we try to adhere to a few basic software development best practices, including testing. So we use a Google test framework, which is a pretty easy to use C++ open source framework. And we'd like any new substantial contributions to come with tests that indicate how the code should be run and what the expected inputs and outputs of the code are. And we'd also ask that you fix any compiler warnings that you introduce, simply because these can be problematic when building cross-platform, and we'd like to try to keep it clean. And then we'd also, for code conventions, we'd just kindly ask you to please try to broadly adhere to the same style of code in the area that you'd be working in. And then for substantial changes, we'd also ask that you comment your code and provide some documentation to us about what it does, simply so we can put that into our help documentation so other users can use the great code that you've contributed. So the way that we handle new feature requests and bug reports is using GitHub issues. And so if you discover a bug in the code or want to add a new feature or just have a general question, you can use GitHub issues to tell us. And so it's fairly easy to use. It's basically just a message board where you can specify the type of feature, and then we'll get back to you as soon as we can. So moving into some of the technical details of actually building SAM open source, we won't go through them extensively. I just want to point out that on the README page for the SAM open source code, we have quick steps for building SAM on different platforms. And we're in the process of supporting CMake for all projects in the attempt to make the build process a little more streamlined. This isn't, I believe, currently in the develop branch, but it very soon will be if it's not. And we're also in the process of making LK, WEX, and SSC Git submodules of the SAM repo. So basically you can, if you're interested in building SAM, you can just build one project instead of 4. One thing that you have to do when you build SAM, if you want to run the open source desktop application with full functionality, is to set up API keys. And so these are keys specifically to do things like downloading weather data from the NSRDB and using things like the utility rate database. And so there's one file in the repository called private.h that outlines exactly what you need to do in order to get those API keys and which ones you need to set. And this is only required, again, if you need to use features in SAM that require external API calls. And so I just wanted to highlight this. And we'd also just ask you to be careful and not check your private API keys into like a public repository. Another thing that's not necessarily straightforward with the open source code, but it's actually not too difficult, is to edit the user interface. And so to edit the user interface, you can simply open your open source version of SAM that you've built. And so I'm going to go ahead and open one here on my computer. And when you open this open source version, it also tells you conveniently, please set up API keys, see private.h for details. So if I just really quick go into PVWatts model with no financials, I get some warnings about default values not being initialized because I'm on a feature branch that isn't fully fleshed out. But say, for instance, on the system design page, for your custom application, you want to add an input variable somewhere on the page. So if you click Shift F7, this window will pop up that gives you information about different things that you can do within the user interface. And so you can do things like add a new configuration. So if you want to do something like, so if you wanted to add a new technology here like marine hydrokinetic, or if you had a different financial model that you wanted to add, that would be done in startup.lk. Also, if you wanted to add new pages to the model itself, that would also be done here. If you want to edit a user interface page, then you go to the user interface tab. And as I was discussing the PVWatts system design page, I can try to find it here. I'm not even sure if I remember. Yeah, it's just called PVWatts. And so here you could do something like change the name of tilt to the way the panel is faced or is oriented if you wanted to change text or change default values or something like that. And so there's also the concept of equations and callbacks in here. So if you wanted the user interface to make some custom calculations that are then sent to the model, you can do that here. And so what this is showing, for example, in this equation is that the losses that are actually sent to the underlying PVWatts model are a combination of the losses that are input in this table here. So we're not passing each of these losses individually to the model, we're just aggregating them and applying them as one bulk loss. There's also the ability to add metrics. So if we run PVWatts here, there's a metrics table. You can add additional metrics there. Cash flows are also something that you might want to interact with. And so in this case, I've chosen no financial model, but if there was a financial model, there'd be a cash flow tab that you could look at. And I don't need to necessarily go through all of these tabs individually. Suffice to say, there's various features of the user interface which you can add to, extend, or modify. And once you've done so within these pages, you simply need to save. And then the most seamless way is to close the case that you're working in, and then go back here and do restart. And then once you've done that, the changes that you've made in those pages should be reflected in the new case that you open up. And so I'll leave it there for now, but definitely send any questions if something isn't clear or you're having problems. And now I'll quickly move into the SAM Software Development Kit. So the SAM Software Development Kit is a collection of developer tools and documentation for basically creating models using the SSC library. And you can create your own applications doing this. And so there's several languages that we support for this. Probably the most used to date would be Python. There's also a lot of folks using PHP. And we actually have some new projects with people using the iOS SDK to develop smartphone applications. And so we've made an effort to support many of the major development languages. We clearly can't necessarily support them all, but we do our best. And so if there's anything missing, we're always happy to either get your help in developing a new wrapper or learning how we can help. One of the nice features of SAM and using the SDK is that you can use a case that you've created in the desktop version to generate code specifically to use in your own application. And so you essentially create a case in the SAM desktop app that reflects the default model that you want in your application. Then you click on the drop-down, go to Generate Code, and then select the language wrapper that you want to use. And then SAM will output the library, either a DLL on Windows or a shared object on Linux. And then any relevant language code and inputs which you then need for incorporating that. And so, again, just as a quick example, if I start a new project here, PV Watts, no financial. And then if I go to generate code and say I do PHP and create some new folder to export it to, it'll pop up with that folder. And then in this folder will be the DLL that you need to include in your project, as well as the PHP code. And so if I go back to the slides, I took a snippet of the code that gets generated in PHP so you can actually see kind of what it's doing. And so we don't need to walk through this in a great amount of detail. Suffice to say, we create some data, a data structure in PHP. We populate that data with the defaults that you've selected in the case. We create the PV Watts model, and then we go ahead and try to execute it. If there's an error, we report it. Otherwise, we free the module, and then you can also grab data out of the data structure that has been created. And so the slides, which will also be distributed, outline some of the ways that you actually call the SDK. And so how to set data, how to get data, and it's all exposed in our ssc.api.h file, which is essentially that interface that you can base your code off of.